Hello, Algebra 2. We are now on to Lesson 2 from Unit 3. We are still on Standard 3.1. So you did yesterday some basics with function notation. And now we're going to look at some of the key features of a graph and even or odd behaviors. So even our odd functions. So this first part that we'll kind of breeze through, I'm not reading all these to you. I'm sorry, folks, but you don't want me to do that. This is all review. All this vocabulary is review from Algebra 1. So see how it says review from Algebra 1. So I'm going to do this. I'm going to explain them as we evaluate this first example below. Okay, so it says use interval notation to determine the following about the graph to the right. So when a graph is increasing, okay, when a graph is increasing, you always look at a graph. Let me first start out this. You always look at a graph from left to right. Okay, so I'm going to look from left to right. I'm going to go across. Okay, so I'm going to start here and I'm just going to work my way across. Okay, when I'm going increasing, that means I'm going up a hill, going up the hill. So I see, and when we talk about these, we talk about it in terms of x's. So I start here, and I definitely am going up a hill here. See that? Okay, going up the hill. And then I'm going across, and I'm going down the hill. So this is the only section I'm going up a hill. So I'm looking at that going, okay, what x value does it stop going up a hill? And it stops at -2. Excuse me, I got a frog in my throat. Not a literal one, but a figurative one. So I'm stopping at -2. So anything though, but notice there's an arrow here, right? So if I looked at anything to the left, all negative infinity, if I stopped at anywhere at negative infinity, I would continue to going up the hill based on what I see in this graph. So what we say is okay, from negative infinity till -2, we are always going up a hill. And then at -2, we stop. So when it changes from -2, I want to make this neater, I'm sorry. When it stops from at -2 and then it goes like straight across, this is the next block that we're talking about. Okay, this is called the constant. It's not going up, it's not going down, it's constant. But at -2, when it changes from increasing to constant, it is neither one or the other. So that's why we put a parenthesis around it. Remember, parentheses are the notations where it doesn't include it. Brackets include it. So basically, for these, we never use brackets. Okay, so don't ever use brackets for these. All right. In positive and negative, you probably won't often either, but there is one exception, and I put it in here, so we're gonna have to talk about it. All right, so yeah, we're gonna have to talk about it. So where this is green here. Okay, so that's where it's constant. So I'm going to jump down here and I'm going to use the constant terminology. So from when x is -2 to when x is 3, so from -2 to 3, we have constant. It means it goes straight across. And then from 3, notice, to 8. See that right there? Right there? That is, so from 3 to 8, it is going down the hill. So starting at when x is 3 to 8, it's going down the hill. Now I know at 8 it stops, but we never use brackets for the increasing and decreasing. okay? Let's change the colors up. You know how I like to do that. All right, so positive. Positive is anything above the x-axis. So I'm going to erase all this color if that's okay with you, because you can always go back and look at it later. Let's do purple. This is Reese's favorite. Okay, positive is anything that's above the x-axis. So positive means any y values that are positive, right? So, but we don't want to talk in terms of y's. When I describe it, I'm going to talk about x's. So I'm going to say starting at what x value does it start to be positive and when does it stop to be positive? So when x is -6, it starts to be positive, and when x is 5, it stops being positive. Okay, again, parentheses, because when x is -6 and when x is 5, the result is 0, right? So at -6, the y is 0. At 5, the y is 0. And 0 is neither positive nor negative, so that's why, again, we put parentheses around those two. Okay, so when is it negative? It's when it's below the x-axis. So let's do orange here. So right here it's below, and here to here it's below. So I see, again, there's that infinity sign, right? So we're going to say from -infinity, any x value going forever, to -6. At -6, it stops, right? And now it's 0. So I'm going to put parentheses. Then it picks up again, so we do a union. From 5, okay, to when x is 8. Now, when x is 8, because now this is the exception, and I'll be honest with you, I don't think they're going to test you on this. This is an Algebra 1 standard, so on the regions, they're not going to be doing anything like this. But we throw it in here just so that you can have a little taste of it for the future. So at 8, we know it's definitely going to be a negative value. So when x is 8, the outcome is a negative point of -4. So we know that that's negative, so then we put a bracket for that. But no other time, really, are you going to be doing brackets for, like, the increasing, decreasing. It's never. Like, you never use brackets for those. That's always parentheses. So, and I'm not going to trick you on that. We're not going to end up doing anything where it's safe to say that if I give you a positive or negatives, we're going to always be using parentheses. I'm not going to stop it right down below somewhere. It's too tricky. So that's the only time that you'll see a bracket. Okay, domain and range, however, totally different. Can be brackets, can be parentheses, okay? So could be one or the other. Let's do, probably haven't we used, did we use that green? We didn't use this one. Okay, so domain is left to right, and we've done this already. We did this in the last unit. So I look at it and I go, does it go left forever? And we're going to say, yes, it does. So we're going to say -infinity. And I always wrap infinities with parentheses. And then what x value does it stop at? It stops at when x is 8. And it includes a point at 8, so I'm going to use a bracket. Okay, then let's use black. That's boring, but let's use it. So range, it's the lowest it goes down to is -4. And there is, oh no, I'm lying. Totally lying. I'm lying. I just lied to you. Because remember, it goes down and down and down forever. So I missed that. Good thing I took a peek, because I normally write stuff on my notes on the side to say, in case I forget to say something. And I was like, oh, wrong answer. And then it goes up to 3 and stops at 3. And there's a bracket there. Okay, so I think I got everything on that. It's so colorful. All right. So does this graph have any relative extrema? So we're going to say no. A relative extrema is anything where like it changes from increasing to decreasing or decreasing to increasing. So it means it's either going to have like a peak, right? Or what I call a valley. So no, the graph never changes from increasing to decreasing or decrease to increase. Like it has to actually have like a hump. So when it goes increasing, when it goes from increasing to a constant, that's not extrema. Okay? So let's go to the next page. That, my friends, is all review for you. What, oh gosh, here we go with the picture. I do not want to make myself any bigger than that, especially since I have my glasses on. You don't need to see that close. Okay, so this, my friends, is the new stuff. All right, so we've got another key feature that we should be able to determine about functions is whether they are what they call even or odd or neither. Okay, so an even function, now this takes a little bit, so you gotta stick with me on this. This page is a little bit heavy, but you really gotta pay attention. And if you get stuck, stop and kind of rewind, okay? So if it's even, if I have a function, let's call it f of x. And if I want to look at it and if I want to check it algebraically, if it is even, then when I put negative x into the function, it will match the original, okay? And I'm going to do examples of every single one of them. How do I know something's even graphically? It is symmetric over the y-axis. So you never knew this before, but like a parabola like that, where it's, if I were to fold it at the y-axis right here, that parabola, not shifted left, right, but just a parabola that's like right in the center, one part of the origin one, the parent one, or the parent function. If I can fold it at y and it's symmetric on both sides, then we know that that is what we call an even function. Okay, so what makes an odd function? An odd function is that when I go to put the f of negative x in there, into the function, it's equal to the negative f of x. And this graphically is symmetric over the origin. Now what that means is if I were to flip it upside down, if I were to flip the paper 180 degrees or upside down, then that picture upside down, the graph would look exactly like the original picture. So if you can imagine taking this piece of paper and rotating it 180 degrees, this graph would look exactly the same as it does right now. Okay, so that picture right there, and that's actually a cubic. This is a y equals x to the third. The cubic graphs all are, that original cubic graph is an odd function. Okay, as long as it's not moved, shifted left or right. Okay, so let's actually do this. Let's determine if the following functions are even, odd, or neither. So we got even, odd, or neither. And then we have to explain. So I'm going to look at A. And I think if I were to fold that at the y-axis right now, that absolutely would be symmetric. Now, remember what we said here. In even functions, if we can fold them at the y and they're symmetric, the left and the right match. That's even. So we're going to say even because symmetric over the y-axis. Okay, how about B? So if I fold it at the y-axis, does it like, if I fold it here, do I have the exact same picture on this side as I do over here? No, I do not. That is not even. Okay. What if I were to rotate it 180 degrees? Well, if I were to rotate this 180 degrees, kind of try and visualize that, it would end up here. Like, see how it's down below the x-axis? Well, if I were to rotate it 180 degrees, it would end up on the top. It would end up there. So the original picture does not look, it doesn't look the same. So we're going to say neither. And your reasoning, because you got to explain, and we're going to say because it's not symmetric over y dy, the y-axis or the origin. Remember, the origin is like 0, 0, right? Okay. Now, let's take a look at that function. This is actually, that's a trig function. You're going to graph those bad boys this year. Woo! How exciting. But for now, you just have to look at it and go, okay, is it symmetric across the y? So if I were to fold it at the y, does the left, does it have a match exactly on the other side? And it would have to go like that, right? For this, like for this red part to be symmetric, it would match the blue, right? So that's not the case. So I can safely say that that is not an even. Is it an odd? So if I were to flip the paper 180 degrees, and literally if I was in front of you right now, I'd make everybody in the class take their paper, right? So here's mine. I would take it and I'd make you flip it upside down and then look at it and look at the board and see, do they match? And we would say, why, of course, Mrs. Reese, we do. They do match. So it's odd because it's symmetric over the origin. All right. Now, I think that's not terrible. I think where you really got to pay attention is when we do it algebraically. So you really got to be careful with these, okay? You got to really, really focus for me on these. All right, so I'm going to determine algebraically if it's even, odd, or neither. Now, we always test for the even first and then the odd second, okay? So the even test, if you remember, let's go back up here, and I said to you guys, algebraically speaking, if it's even, we put in a -1, negative x. If it's odd, we put a negative in the front and test it. And then we have some stuff to do with that. Okay, that's just part of it. Okay, so let's come back down here. All right, I don't like that pink, it's too light. So where's my hot pink? Where's my hot pink at? Is that hot pink? Let's try it. So not really, that's the red. Anyway, so I'm going to put that negative x in for all x's. So we basically, the test is f of negative x. So I put that in. You really got to be careful of how this is working. So if I think about order of operations. If I take negative x and I square it, a negative x and a negative x make a positive x, right? So this comes out as a positive x, and then it's -3 again, right? X plus 1. Okay, so f of negative x is equal to -3x squared plus 1, because when I square that negative x, it just becomes a positive x squared, and then I multiply it by -3. So then I go back and I go, all right, does that match? So they match, which means, what is they? The f of negative x and the original function f of x match. So I can stop there. I don't even have to test for odd. If even works, if even tests and works, I'm done. That's actually the easy part. So then we're going to say it's even. You know what? It's even because f of negative x, right? That when I put the negative x in, it's equivalent to f of x. And if you remember yesterday on your notes, I had you I left your notes open to try some of these. And that's why we put it in. So we're going to actually go through and talk about that when we come back. Okay, so that function, if I were to graph it right now, I know that it would be symmetric about the y-axis. Okay? Okay, so now we're going to go to B, and we're going to test this one. We're going to try this one. All right, so again, always try the even first. Okay, so I replace every x with a negative x. And I say, okay, negative x cubed. Negative x cubed just means negative x times negative x times negative x. And if, let me say this to you, and I know I've already mentioned it to you. If the negative x, or when you're squaring a negative versus cubing, if the exponent is odd, then the actual result is a negative. So because that's an odd exponent, this ends up to pop out to be a negative x cubed. If it was an even exponent, like negative x to the fourth, like negative x parentheses to the fourth, that would end up to be a positive value. Okay, so that's odd. So that ends up to be a negative x cubed. And then I've got a negative x to the first power, which is negative x. So negative x times negative 11 is positive 11. Okay, now remember, I'm testing for even here. So I come here and I say, no, it does not match. So then I'm going to, oh, there's a color. And then I'm going to go, all right, I've got to then test for odd, okay? I've got to now test for the odd because the even test didn't work. F of x does not equal f of negative x. Okay, so I remember what the test for odd was. Test for odd was I've got to use that f of negative x, but I also have to do this. I have to do this negative f of x, which basically means, I'll show you, which basically means that I put a negative in front of the whole entire function. See that? I stick a negative, I put parentheses around the function, I stick a negative in front, and then I distribute the negative. Right? So watch what I'm going to do. I'm going to distribute it so every sign flips. Okay? Then I come up here and I go, okay, does the negative f of x match the f of negative x? So I compare it. See, I got to be really, really neat when I do all this, by the way. You got to really be methodical and neat. So they match. So I can say it is odd, and you have to have, I'm remiss in saying this before. You have to state odd because f of negative x equals negative f of x. Okay? So you have to make those statements just like we did for this even one. You got to do it for the odd as well. Okay? And you got to show all that work, just the way it is. Okay? There's no way out, so don't try. Got to show the work. Don't be lazy about it. All right, so now C, going back, and I'm going to check the even first, which means I'm going to put negative x into the function. I got negative x to the fourth plus just a negative x by itself. Okay, remember I said if if the exponent is even, then it automatically comes out as a positive x. So this becomes 2x to the 4th, but because this doesn't have an exponent only of 1, this is just negative x. Sugar roasted peanuts, hold on. Okay, now I go back and I go, does that match the original? So I say no, so it's not going to be even, right? Definitely not going to be even. Trying to be specific. Okay, so now we're going to test for odd. Let's go through and test for odd here. We'll color coded. So this is my odd test. Right, so I put a negative in front of the whole function. And I distribute it. Oh boy. Oh boy. And it's supposed to, if it's odd, remember it's supposed to match. So now look what I'm going to do. I'm going to check to see, does it match my f of negative x? And those two functions, they don't match. They're close. But see, the f of negative x, the 2x to the 4th is a positive, but down here it's a negative. So because that is the case, then we don't have either. So we're going to say it is neither. So, and you've got to state this, f of x does not equal f of negative x, which would be even, and f of negative x does not equal negative f of x. Okay? So you got 3 scenarios there, even, odd, or neither. Hopefully that helps. And you're going to definitely want to keep these notes out when you go to do your homework for this. All right, so I've got this one, and I believe did I read it? Okay. Hold on, let me open this back up. I thought I had everything stuff. Okay, so you're gonna look at this example 4. So this is on the grid below. Oh no, what happened? On the grid below, graph the function f of x equals, right? Oh, I do have it in here. X to the 4th minus 3x squared minus 4 on the domain. So that means that my domain is what we call restricted. So I'm only going to have the domain from -2 to 2. So I put it in my calculator. Okay, so I went to my y equals, I plotted that in. And then I'm going to go to my table, and I'm going to go to just where that domain is. Let me see if I can bring this up so we can look at both. Oh, look at how fancy I am. Okay, so I'm going to do I want to do the points from when x is -2, right? It says when x is -2 to where x is 2. So -2 is 0, -1 is -6, 0 is -4, 1 is -6, and 2 is 0. Plot the points. I will tell you right now it's going to look like that, and I want points that are precise, please. Make sure you're plotting those points precisely. So -2, 0, -1, -6. 1, 2, 3, 4, 5, 6, all the way down here. 0, -4, 1, -6, 2, 0. Oh, I almost had it. It was a little bit messy on that one part. I don't want it to be messy. Oh my goodness. If you can't tell, it's dark in the back. It's getting late, so I'm being tired. There we go. There we go. I mastered it. That's a perfect one. There it is. Okay. So I want you to do this. I'm going to have you answer a couple of these questions. The only one that I want to talk to you about really quick, because we didn't in the rest of this, I think you can do explain why it's a function, identify where it's increasing, determine if it's even on or neither. But I want to talk about label any relative max with an A, or any relative min with a B. So what they mean by relative is they mean based on the picture that you see at this point. Because some other point in the graph, like maybe later on, maybe it does go like down. We don't know. But for now, we're seeing it's always going up. Of course, well, you do have the function, so probably doesn't go back down. But that's why they call it a relative min or a relative max, though, is they want you, it's based on the picture that you see at this point. So a relative max would be where you see a peak. So we're going to put A here, because there's one right there, a peak. And a relative min would be where there's a valley. And it's little. Okay? All right, so you're going to fill the rest of that out. I need the rest of that completed. And example 5, I'm going to hold off on. So it's just an extra one. You don't have to worry about that. Okay, so you have a homework assignment from here, from lesson 2. So make sure that you keep your notes out, do homework. I'm going to be checking for sure both of these when I see you next, okay? So I will talk to you soon. If you have any questions, you know where to find me. Take care.